To begin at Chapter 7, we're going to talk about exploring exponential models, which basically is saying we're going to explore exponential graphs. First, what is an exponential function? This is the graph of an exponential function. A cannot equal 0, and B must be greater than 0 and cannot equal 1. Now, typically when you see an exponential function or a graph, this is what it would look like. It starts out slow and then it increases rapidly. Now, depending on what your B is, your constant, is how fast this might move upward. So it might go up really fast if it's a higher number. If it's a lower number or like a decimal point, it might be a little bit wider. So that's just kind of what an exponential function looks like. If we wanted to graph an exponential function the long way, we first have to make a table and then plot the points to connect, and then connect the points. So first you have to pick your points. Typically you want to pick some negative numbers to some positive numbers. So I am just going to be picking 3 on each side of 0. Now you have to be careful when you're plugging in this x. What this is actually saying, when I plug in negative 3, it's 2 raised to the negative 3 power. When I plug in negative 2, it's 2 raised to the negative 2 power. And so on. So my answer here would be 1/8, when it 2 to the negative 3, 1/4, 2 to the negative 1/2, 1/2, 1, 2, 4, and 8. So now I'm going to plot my points. My plots are my Christmas colors. So my first point would be negative 3, so x is negative 3, and y is 1/8. So just a little bit above the y-axis. And negative 2, it's about 1/4. I know those kind of seem the same, but just do as well as you can. At negative 1, it's at 1/2. At 0, it's at 1. At 1, it's at 2. At 2, it's at 4. And at 3, it's at 8. So this is what the graph would look like. And you should make sure to connect your points and put arrows at the end. So again, this right here is your basic exponential function. Now, when just looking at the graph, it will tell us a few things about the representation of the function. B is the most important. A always has to be greater than 0 if it's going to be exponential growth or decay. And if B is greater than 1, that means it's going to be a growth. If B is a fraction or a decimal, so in between 0 and 1, it's going to be decay. But this information right here always stays the same. The y-intercept will always be at 0a, whatever a is. The domain or the x values can be all real numbers. There's an asymptote at y equals 0. That means that the function cannot go over y equals 0. And the range, y is always going to be greater than 0. So if I want to identify the function or situation as an example of growth or decay, and then pick up the y-intercept. This is my b right here. I have to decide, is this growth or decay? Since it's a decimal with no number out in front, it's not like 1.95, it's just a decimal 0.95, this would be decay because b is less than 1. And my y-intercept is always going to be 0a, so it would be 0, 12. I want you to pause the video and attempt B by yourself. You should have gotten growth because 2 is larger than 1, and my y-intercept would be 0, 1/4, or 0.25. This is like an equation or a formula to help us solve problems. So I'd make sure to write this down. A stands for the amount after your time. That's what A stands for. R is always going to be your rate, and it will tell you if it's growth or decay. Now, if it's a growth, you're going to be adding that to 1. If it's a decay, you would be subtracting. So it depends on if it's growth or decay. A is whatever number you start off with, and T is a number of time periods or how long it's in the situation. So now I'm going to use that formula to solve this problem. So when I'm looking at this, I see a number here. I'm not going to have to know 6th grade, but I see 5% interest, and I say 6 years. So now if I use that formula, I don't know what I'm ending with, so I'm going to keep this the same. And it's saying that I'm starting off with $1,000, so that's my initial amount, so that's my A, little a. And interest means it's going to be added, because that's growth. So I have 1 plus. You have to write this as a decimal. So this would be 0.05. So 1 plus 0.05. And my t here would be 6 years, because it's telling me after 6 years. So you could simplify this to 1,000 times 1.05 raised to the 6, or you could just put that into your calculator. Either way, you would get that your final amount would be equal to $1,340.10. So this problem starts out kind of the same, except it's asking for a different question. It's saying you're still starting off with $1,000, your interest is still 5%, you're not adding or subtracting any money. How long, so what's t, to make at least $15,000? So if I set up this equation, it'd be 15,000 because that's what I'm ending at. My A is still 1,000. It's still going to be a growth, so it's still adding. My percent is still 5%, and I don't know what t is. There's 2 ways to solve this. I'm going to be showing you how to solve this guess and check. So guess and check would say, what's my x, what's my y? Well, the previous problem, after 6 years, I made 13,000. So I know it has to be more than 6 years. What I'm going to do is check 7, 8, and 9 and see what that gives me. Again, it has to be at least 15,000. So if I guess and check my first problem, I want to put 7 into my equation. So I'm going to start with 1,000 times 1.05 raised to the 7th, because that's where my input is. I want to see, what do I get out? I get 1,407.10. Well, that is not at least 15,000. So I'm going to have to check my 8 now. So if I check 8, if I have 1,000, and I still have the same process, except now it's after 8 years, I would get 1,477.46 out. Still not at 15,000, so now I have to check my 9. Here we get 1,551.33. So that's my winner chicken dinner, because it's at least 15,000. So I'd have to have it in there for 9 years. That would be my final answer. Tomorrow I'll show you how you can do this on your calculator. Make sure you took good notes. You have something to show me so you get full credit. And have a great day.